Today I am planning to solve some of the subsets problem which are very frequently asked in interviews. My goal here is to show you the code, very generic code, which can be applied to many different types of subsets problem and solve them. So let's start with solving this problem. Given an integer array of unique elements, return all possible subsets. Yeah, so for example, we are given an array of size 3 and elements are 1, 2 and 3, and we are asked to find out all the subsets of this array. The result size 8, okay, which is 2 to the power 3, and these are the elements, which is nothing but the combination of all the elements of size 1, size 2 and size 3, right? If you look at this closely, they resembles a binary counter of size 3 from 000 to 111, right? What I mean by this is when I say 000, it points to a empty set. When I say 111, it points to this set where the first element exists, the second element exists and the third element. If I say 100, that means the set 1, okay? The corresponding element in that position is in this set. Or I can say if the bit at that position is set, then I am going to include that number into my subset. So this is a very naive approach, iterative solution to find all subsets of a given set. So we are going to return a list of integer, okay, and we call the method as all possible subsets. We'll take one array as our input, okay. Now we say now first is we'll find the size equal to math dot power 2 to the power size of the array, which is array dot length, right? Okay, now we'll run a for loop, okay, for int I equal to 0, I less than size, okay, I plus plus. Fine. Now we'll run another for loop which will run from j equal to 0 and j less than the array length, and this should be j, okay, and what else, submit. Cool. Yeah, most of you might be familiar with this particular program, so I don't think that it needs any further explanation. The time complexity for this particular solution is actually, if you see this, this is 2 to the power n times this for loop will run for 2 to the power n time, and this for loop will run for n time. So the time complexity for this particular problem is n into 2 to the power n. This is good. Now let's see another solution approach, which is also a iterative solution. If you see this particular solution set, from the given array we choose one element, which is 1, okay, take an empty set and then we add it, we include it, okay, and we come up with another subset. Now let's choose another element 2, and we already have this subset. Now we add this 2, okay, to this subset, so which becomes empty set 1 and 2, okay. This 2 actually, we add it to empty set which becomes 2, and we add it to 1 which becomes 1 and 2, right? So another approach I am trying to find a solution for, okay. Let's try to understand how this second approach works, okay. So let's take one empty set and now choose one. So we'll pick one element from our given array which is 1, and we add into the result set. Okay, so after adding this to the result set, 0 and 1, okay, this set. Okay, now we have a result set, this one. So now we'll take another element 2 and we add it to our old result set. We have the old set, okay, 1, and now we are adding 2 to each of our set, each of the subset. Okay, so which is with empty if we'll add 2, and then with 1 if we'll add, it becomes 1 and 2. So now we have another set. Okay, also let's write it like this. This is the result set, this is the result set in the second step, this is the result set in the third step. Okay, now we'll add 3 to each of its set. Okay, so we'll add 3, then 1 3, then 2 3, and then 1 2 and 3, and that's it. So this is the final answer, because we have actually taken every element from this given array into consideration and built our result set. This is our answer, right, which is exactly having 8 elements, 1 2 3 4 5 6 7 and 8 set. Okay, now let's write a program which will do the exact same steps that we did it here. Okay, let's do this, and we will return the result. Yeah, right. Yeah, now what we did, so see, for 3 elements we created 3 times, right? So we created the result set 3 times, and in the final step we got the result, right? I'll do the same here. For int num in array, right? Okay, we started with an empty set, so we'll add one empty set, new array list. Okay, now what we did, so for all the subset in our result set, we are going to run another loop. So I'll call list of integer, I'll call it subset, right? Or yeah, let's call it subset now, in the result, right? Okay, we are creating another subset list, right? So I'm going to create. So what we are doing here, okay, let's see. So what we are going to do here, so we are creating a new set, integer, we'll call it temp, new array list. We are taking all the subset, right? Or yeah, I'll actually call it list, okay, because we are going to create another subset here, temp list. Okay, in the temp list we added the number. See, each time, see, from empty set we started, and then when we pick 1 we added 1 right here, and when we pick 2 we added 2, right? We pick 3 we added 3. So that's what we are doing here. Add num, okay, and now we are adding this list. We are adding this list to our subset, of course. So let's create a subset. Okay, subset, okay, equal to subset equal to new array list, and in this subset add temp. Fine. So for example, we started with empty set, we got the empty set here, we created a temporary. From the empty set we added num. So this is what we created. We had a empty set, we created one here. Okay, now we have a temp list with empty and one element. Now we have added both of that list, both of those list into the subset. Okay, right here. So we have these two. Now we add them, add this both of this subset to our result. Okay, result add all the list which are in our subsets. Now we pick another element which is 2. When we pick another element, we create another subsets. Okay, list from result. Result is what? Result is having this 2 subset. Okay, so we pick one first, which is what is this one, add the number. So we added this number 2. Now in the subset we have added temp, which means subsets we have added 2. Now result is having another one element. Okay, here, right? Now with the one element, so we got 1 here, the temp list is already having 1. Now we add another number to the temp list, which is, after adding, it becomes 1 and 2. Okay, so this list is 1 and 2, and now we added that 1 and 2 to the subset. Okay, so subset, now this subset is having 2 and 1 2 in the second step. Okay, after this we'll add these 2 subsets to our result set. Okay, so we have added 2 and 1 2. We already have 0 1, empty and 1. We have added this. So likewise the third loop goes, and finally we return the result after this complete for loop is over. So if you see this, this is also time complexity will be like, for this loop this is n, and if you see this, every step, for each step we are creating double. First time it ran for once, second time 2, third time 4 times. So it depends on the number of elements which are present in the result. Okay, so for this also time complexity is 2 to the power n into n, because we are copying all the time n number of elements. Yeah, so n into 2 to the power n times. Okay, now let's run this. This is also called cascading approach. In fact, this is the approach that that can be transformed into a recursive solution also. Okay, because if you look at this, what we are doing, we are actually running this loop with the previous result, and we are adding our new, we are creating our new subset, right? I would encourage everyone to master this particular solution rather than this approach. You can see these 3 steps. The first step we are printing empty set and 1, because we have included 1 here. Okay, and the second step, for the second number, right, we are including 2. So this is the final subset. Okay, and in the third step we are including 3 in the previous set. So we have added 3 here, and then 3 in every previous subset. Now let's take a closer look to the results that we have received in every step. Okay. So in the first step we started with a empty list, right. Then in the second step we see a list with 2 elements, right. So one is empty list, another is a list with 1, right. We can actually visualize this as a branch where in one side we did not add this element 1 and in another side we added this element, right. So we choose this here, we did not choose this here, we included this here, we did not include this here. Okay. We had 2 options, either include or exclude. So we excluded here, we included here. Okay. Now let's go to the next step. Okay. So in this next line, what do we see? If you look at this, for the second line we are actually now taking 2. Okay. So we will here, what can we do? We can choose 2 to include, right. So including 2 here. Okay. And here in this, for this particular node, we can again say that we can either we include or exclude. So we will exclude and then 1 and 2 include, right. And the final step 3 excluded for this particular node. If we look at this particular node, excluded 3, included 3. Okay. Here excluded 3, so we still have 2 here, included 3, so 2 3 we have, excluded 3, included 3, that is why 1 3, excluded 3, that is why 1 2, and included 3, that is why 1 2 3. So now we have 1 2 3 4 5 6 7 8. So 8 subset we found. So this is another way of looking into the creation of subsets. So this is also called the KnapSack algorithm, where in every decision tree we are taking a decision whether to include this number or exclude this number. So let's go ahead and write this code. Again, if we look at the structure, we are nothing but constructing the binary tree, right. So it has to look like a binary tree traversal, right. We will call a helper method. Okay. So yeah, let's just call the helper method, and we will definitely have to pass this result to the helper method so that it can create us the result array list, and we will pass the result. Of course, we have to pass the array also. Okay. Let us see how it looks and return result, right. Now our helper will take, of course, the input, also of course the result, we know that. Now, so the base case is if we have considered all the elements, then we are done and we can add that set to the result set. So we have to take a index, right, which element we are right now looking at and taking the decision whether including or excluding. So int, I will say start maybe, okay, or index, whatever you want to. So if the start, if the index equal to the given array length, then we are done. We can add it to the result set. Okay. Add what? Add what? Because every step we are creating new subset. Okay. In every step we are creating the subset. So that list we have to add it to our result set. So I can say list integer, and I can say maybe temp or subset or whatever. Okay, maybe we can call it subset, right? And I will add this subset to my result when my start equal to array of length. So when let's say start equal to 0 and array does not have any element also, it still add a empty subset, you know, when we send a empty subset from outside, because anyway that is the first step, we add a empty subset to start with, right? That's how we started our branch, right? Yeah, okay, and we'll return, right? Fine. Now what will we do here? Okay, fine. Now what we need to do, we'll call this helper method, pass the input for the next index start plus 1, right? And the subset in the subset, and the subset of course, and the result. We have to call this helper method 2 times, right? We have to call it once without including the element, without considering one element, right? Considering the current element, you can say the current element is what? Current element is array of start, right? So in one recursive call, if you see in one recursive call, we are not including any element, right? We are just going to the next step, next index, that's it. We are not doing anything else, right? In one recursive call, every time we are going, we are actually creating new list. So we have to call this one with array list, new array list, okay, new array list, okay. Here excluding or not considering the index, which is array of start. The next recursion will be called by considering this or including this element in the subset, okay. So subset dot add array of start, okay, and then we copy the subset and we call the recursion, okay, and that's it. Let's now apply this particular code and see how it looks, okay. So if you look at this code, it looks like a in order traversal, right? Now let's just run this, okay. I am calling this subset for 1 2 3 starting with 0, passing an empty subset to start with and expecting a result, okay. I am printing the subset here so that we know in every step what we are getting, okay. Let's see, okay, let's see this. So yeah, so here we have to pass 0 and new array list, right, empty array list. Yeah, accepted, and now submit. Cool. See, I mean this is faster, right? You see this KnapSack approach, this approach is much faster than the iterative approach. So in the first iterative approach it is n into 2 to the power n. In the next iterative approach it should be little faster, actually it should be little faster than this, even though the time complexity is n into 2 to the power n, because this complete for loop, if you look at this one, this is 2 to the power n, okay, and the extra time that we are spending is in adding the subsets here, okay. For n number of step we are copying the subset into the result set. That's why it has to be again n into 2 to the power n. Yeah, this is very good. We already found a very good recursive solution to find all the possible subsets. But let's try to analyze this again. I just want to remind you that these are nothing but the combinations of all the elements taking 0, 1, 2 and 3 length, right? This is actually the extension of the substring problem. Okay, you know how to find all the substring of a given string by using recursion, then it's a very small modification to that code. Let's revisit this solution set again. Let's look at this particular tree again. Let's see this. We started with empty set, we added 1, right? Then we added 2, then we added 3. Okay, we have added all the elements and we cannot add any more elements. So what will we do? We'll go back, okay, one step back, and if we just to go back one step back, okay, what does it mean? If we remove the last element, so let's remove this 3 from here. Okay, so if we remove this last element, then we will be left with 1, 2, right? And here we ask ourselves, can we add a new element from the given set, from the given array? And actually we cannot, because that's what we did. We added new element and that's how we reached 1, 2, 3. We cannot, so we'll go back again here. Okay, now to this set, can we add another element? Yes, we can. Yes, we can, which is nothing but this one, 1, 3. So if you see this, this is how I'm going. See, I started with empty set, then created 1, then 1, 2, then 1, 2, 3. Now I go back, I create 1, 3 now. Okay, go back, I cannot add 1, 2. So now I don't have any other option but go back to the root. And can I add a unique element to create a new set? Yes, I can, because right now I am done with the first index. Let me try to revisit this again below. Okay, so we are given a list of elements 1, 2, 3. So we started with an empty list. We consider 1. Okay, so we take 1, then taking 1 we will add another element. Okay, so which is 1 and 2. So we have added 2 to this list. Okay, now another element can we add? Yes, we can add another element to this list, 1, 2, and that is 3. So that's 3. Okay, can we add any more element to this list? Yeah, we are done with this particular subset. Now how can we build another subset? Let's say by some means we'll remove the last element. Okay, we can remove the last element, and if we can remove the last element, then we'll go back to this subset. Now can we add anything new to this element to create a new subset? Actually not. We cannot create any new element by adding anything to it. So we go back. Okay, go back. Now here, can we add any new element to 1 and build a new subset? Yes, we can. We can add 3 to it, right? And can we add anything new to this subset? No. So for we consider the I equal to 0 and we created this many subsets, and now we will take I equal to 1. Okay, so when I equal to 1, that means we are taking 2. Okay, and we will try to form a very similar tree here. Okay, when I equal to 1, this is the first subset we will create with 2. Start with empty, so we went to the root and we will consider 2. So we have another option which is 3. So we'll add 2, 3, right? I don't have any other option but go back. to root, right? Now I'll take the last element, which is I equal to 2, right? And for this I don't have any other option but just to consider 3, right? Can I add anything else? No, I don't have any other option. Okay, so this is another way that we can create all the subsets, right? This approach is called backtracking. So this is very, very important. Okay, when you are writing a code, you should be able to explain the output. Let's say you are asked this particular question in a on-site interview, in a whiteboard interview, then the interviewer might ask you to print the solution taking some examples. I think this will be very clear when we will see the output of this particular solution versus this solution. Okay, so this is my helper method. I will call it now backtrack. Okay, backtrack. And if you see this, every step I am printing my subset. Okay, I don't care if it is like this condition. If you look at this condition, you know, the helper method that we wrote, we had a condition here, start equal to length, then we print the subset, right? But here in our case, we don't care about the length, right? We just actually consider 0 length, 1 length, 2 length, and 3 length. So almost all the length we are covering, so we don't need this actually here. Okay, so we add every subset that we create to our result set. Okay, now we call the backtrack for all the index, right? Int I equal to 0 to I less than r dot length I plus plus, right? So we have a for loop. Okay, we call the backtrack, right? Adding the current index, right? So I'll call subset dot add r I, right? And we call our backtrack method. Okay, increasing the index to the next index, right? Okay, we pass the start. We start from start here. Okay, you can keep it like this, or you can actually send it like this, and we add it with array list here. Okay, both are correct, not a big deal. So I'll remove from here and remove these 2 lines also. And as I said, after the recursion is over, subset dot remove the last number, right? Which is, how do we do it? Subset dot size minus 1. Okay, I think it is now clear how did we, you know, recurse for I equal to 0, then I equal to 1, and I equal to 2, right? So we removed the last element here. So this is the method. Okay, all possible subset. We can call backtrack also. Let's I don't want to change it. How will we call it? We'll call with 0, and exactly same way how we call the other recursive solution. Okay, first empty set, then 1, then 1 2, then 1 2 3, then we remove this 3 last element. Okay, we go back to 1 2, and we see, can we add any more element from the given array? We cannot. Then we go back to 1 again, and we ask, can we add any more element to create a new unique subset? Yes, we can. What is that? Okay, that is 3. That's why we see 1 3 here. Okay, now from 1 3, can we add any more element to create a new unique set? We cannot. Now we go back again. We'll go back to 1 by removing 3. Okay, now we'll start with the second index, which is here, 2. Okay, so when we consider 2, then we recurs, we call the backtrack method again here, take the next element which is 3, after 2 we add that, right, that's why 2 3, and finally we backtrack and finally we consider 3. So you see this is completely different from our old solution, from the other approach. Let me just run that for you. This is how the output looks like right now. If I just run the other method, which is just above this one, see, okay, now let's run this. Okay, now let's submit this. Cool. Yeah, again for this one also the time complexity is 2 to the power n, because see, for the first index how many elements we have created? 1 2 3 and 4. For the second one 2, the final one 1, right? So each of this step we are decreasing by half, okay, but whatever it is, it is 2 to the power n number of elements we are creating, and again there is a copy of the elements are involved. So at max we will be copying n number of element n times, okay. So anyway, from this observation we found that the KnapSack approach, right, that is the best approach we can take while solving such a problem, if we want to beat the time of LeetCode at least. But this is very important, guys. I would encourage to always follow this approach to solve subsets problem, okay. Why? Because if you remember this code or you understand this code, you know the format, you can solve almost all type of substring, subset, permutations, combinations problem. So anyway, if you are already watching this, I would encourage you to watch the second part, okay, in continuation of this particular session. Trust me, it will be worth second part of this video, because I am going to apply this particular method for solving other different problems, okay. Yeah, I always say that if you know one approach, master that approach. So that's it for today, guys, and hope you like this video. Thanks for watching, and please consider subscribing so that it will help the YouTube algorithm to grow this channel.